Welcome. We'll be looking at projectile motion problem 23 of the WebAssign. We are told that a ball moves towards a wall at a speed of 22 meters a second and that the ball is thrown at an angle of 40 degrees above the horizontal. The wall is 22 meters away from the release point of the ball. There are 4 questions we must answer. The first thing we must find is how long it takes for the ball to reach the wall. We know the ball's initial position and its final position, which is 22.2 meters. And we also know that since we're dealing with horizontal movement, there will be no acceleration due to gravity. By creating a triangle with a hypotenuse of 22 and an angle of 40 degrees, we are able to find that x, the horizontal component of the initial velocity, is equal to 16.853. Next, using this equation, df is equal to di plus vit plus 1/2 at squared, where t is our only unknown variable, we are able to find that t is equal to 1.317 seconds. Next, we must find how far above the release point the ball hits the wall. Even though we have most of our x components figured out, we now need to find our y components. What we do know is that it starts at y equals 0. It takes 1.317 seconds to hit the wall, and it is experiencing a downward force of gravity of negative 9.8, and that force is constant. By creating another triangle, we are able to find that the vertical component of the initial velocity is equal to 14.141. Using the same equation we used before, we find that the ball hits the wall 10.125 meters above the release point. Our third task is to find the horizontal and vertical components of the ball as it hits the wall. We already know that since no horizontal forces act on the ball, its final horizontal component will be the same as its initial component, which we know is 16.853 meters per second. We can find our vertical component by using the equation final velocity equals initial velocity plus acceleration times time. When we plug in the variables we know, we get 1.234 meters per second. Lastly, we must determine whether or not the ball has passed the highest point on its trajectory when it hits the wall. Using the equation, final velocity is equal to initial velocity plus acceleration times time, and setting the final velocity is equal to 0, we can find the exact moment the ball begins to move downwards. Plug in variables, and we find that that time is 1.44 seconds. Compare that to the time that it hits the wall, and our answer is a big fat no.